please take the floor.
Good evening, everyone. Can you all hear me?
Yes, we can hear you, Abdul. Right down.
All right, so I'll be sharing my screen now, and I'll call on my team members so they present as I share my screen. Can you all see my screen?
Yes, we can.
Yes, we can.
All right, so ours is divided into 5 parts. Kule will be taking the first part, that's provisioning the infrastructure with Terraform, and containerization will be taken by Paul, and the third part will be taken by Kunle, as deploying with Argo CD. So the fourth part will be taken by Umar, setting up the observability stack, and then the fifth part will be taken by Kabir Bello, as the Velero backup. So Kunle, if you can see my screen, you can start. Are you there?
Are you here? Okay. Only here. Here.
Can someone start on his behalf or just start? Do you not have that time?
Right, is Paul, are you there?
Can you please scroll the slides downward so that we can kickstart? Hopefully,
Hello, can you hear me?
please having. Okay. Okay, we are joined back. Only, are you here? Hello, Kunle.
Everybody hear me? I can hear you.
Yes, we can hear you, Kunle.
Okay. So, can we go back to the overview? So, this is our project, and we are to build a PD delivery platform, a secure Kubernetes, observatory Kubernetes framework. So, this is our architecture diagram, and all this presentation is going to consist of what is inside this architecture diagram. So, can you scroll down? So for the core challenge and what we are going to build, we are to deploy a application to Kubernetes, and it's about building the entire platform around Kubernetes system. So we start by deploying our infrastructural part, which is using Terraform. So I'm going to explain how we build our infrastructure using Terraform. So can you go back? Can you go up? Start from where my name is stated. So we are provisioning the infrastructure with Terraform, and everything starts with infrastructure rather than we using manual creating of cluster on our cloud provider. So we are going to be use Terraform for the provisioning of the cluster, and all our Terraform all our Terraform code is stated on Terraform and on inside our Terraform folder. So for the Terraform, we are going to have a general purpose internet facing resources. We have a GKE node, and also we have port IP range, and we also have service IP range. So can you scroll down? So our GKE cluster runs as a private cluster. Is only the node private cluster node and have no public IP address. So all the outbound traffic goes through our cloud NAT, and SSH is restricted to our Google identity. So this is the Terraform code for the GKE. Our cluster name is Mini Finance GKE cluster, and the node pod. So for the node we use EE2 standard instance, while with 2 GPU, 8 gig RAM with auto-scaling from 1 to 5 node. So in case our cluster require more resources in the auto-scaling, we just spin up a node or up to 5. So this is our Terraform apply command showing successful after we apply our Terraform command. And this Terraform command create our GKE cluster, and this is our GKE cluster overview inside our Google Cloud. Let's scroll down. So here is the image of our cloud on Google console. Thank you.
Thank you. Mr. Paul, are you there?
Yeah, hello, can you hear me?
Yeah.
You can hear me, right?
We can hear you, Paul.
Okay. My name is 𝗘𝗍𝗽. I'm the one that did the CI part. CI means continuous integration. For this project, we had a static website named Mini Finance website, which has some features like overview dashboard, wallets, profile management settings, FDEX, and transaction history. If you scroll down to the screen, you will see the picture of how the website looks like. Use Nginx to load the website using port 80. We also use Nginx paper to make it smaller, and we use APT. We use APT to make for couching rather. Please can you slow down? So this part is building the CI pipeline. In building the CI pipeline, we have a Docker image, and this our Docker image is our Mini Finance app. We have ci.yaml file. In this ci.yaml file, we make changes either in our main branch or our developer branch. We push the change. When we push the change, we have Traven that checks for security availability. If it passes the security, it's loaded. We start building the we have in the CI flow, we have the build scan. So if the security check pass, it's build scan, and after that one is done, it's now load our image on our Docker Hub, which we have already synchronized our Docker username and password already. So here we have manifest. We have two manifests. We have the production and the developer manifest. Please, can you scroll down? Go down. You can still go down a little bit. We can stop at how it works. So, sorry, the GitOps workflow action. So as I've said earlier, we follow about 9 steps. The first step was developer push the code from the develop or main branch. The GitOps trigger the action on the CI workflow. The workflow builds a Docker image and tag it with a commit message. We have a commit message that I said earlier. To then scan the image for vulnerability if it passes. If the scan pass, the image is put to the Docker image, which I've said, and the workflow is updated on our Kubernetes manifest, either on our production or our dev manifest. The workflow then push the change to Git. Then we have Argo CD, which detects the manifest change in Git. After Argo CD have detected the manifest change in the Git, the Argo CD synchronize the cluster to match the new manifest and develop the new image. That's what I did on the CI. Thank you. I'm done.
All right, the next part is deploying the Argo CD with GitOps. 𝗘𝘅𝗽𝗍, are you there?
Yes, I'm here. Can you scroll down for the Argo CD part? So for the Argo CD, we are using Argo CD as our continuous delivery. Can anybody hear me? Hello?
We can hear you
Yeah.
clearly.
Yes, go ahead, Kunle. Go ahead.
Okay. So we are using Argo CD for our continuous delivery. And why we are using Argo CD is that we want our desired state to be our current state to also be equal to our desired state. So what Argo CD does is that anytime there's a new commit into our Git repo, Argo CD monitor our Git repo and make sure this new commit, these new changes works with what is inside our cluster. So we start by installing Argo CD, which we install Argo CD from the official Argo CD manifest, and we create a namespace for Argo CD where we install the Argo CD. And after we install the Argo CD, we make sure that the Argo CD is working by verifying all the Argo CD port is working. So we verify that the controller, the Argo CD repo, the Argo CD application set, all of them are working. So can you go down? So these steps as how we can access our Argo CD. So we are using the default by port forwarding our Argo CD. So why we use the port forwarding is that we want to limit people that have access to our Argo CD URL to only the people working on the cluster. So that's the only reason we are using the port forwarding for entering the Argo CD UI. So and also there are different types we can use. We have the load balancer service, we have the ingress, but we just choose to use the port forwarding for accessing our Argo CD UI. So can you go down small? So I'm going to explain this GitOps and Argo CD role. So it's okay. So GitOps is a declarative approach to continuous deployment, and as this as our source of truth for our infrastructure and for our application. So what this means is that anything we declare into our code is what also inside our cluster. So let's say we change from our manifest code, our deployment code, we change maybe the pod to 2. We want that tool that we commit to also be the tool that is going to be inside our cluster. So what do this for is Argo CD. Argo CD will monitor the repo that is connected to, and it will be looking for if there's any change. If there's any change, Argo CD will make sure that this change will also apply to the cluster. And also, why this is a very okay in the benefit of this is that you have this rollback capability. Let's say there's this the deployment with the new deployment, maybe it doesn't work. We can roll back to the stable deployment, and this can also, and let's say we can track if any commit is made. Argo CD can track the commit history and check who made the commit and all of that. Accountability. So with help of Argo CD, this can be achieved. So from our repo, from our Argo CD repo, we have different in different directory. One of we have like 6 directory. We have the fundamental directory. We have the in the add repo. This all this repo talk about how we use Argo CD in manifest to set up our application. So I will talk about the CI/CD GitOps workflow. When the developer commit the code to maybe the main or the develop branch, GitOps action will build and scan this image, scan the Docker image with the commit tag. So the pipeline update the manifest, and the Git the new image tag. So pipeline commit this push and the manifest change back to our repository. So Argo CD will detect this change in the next synchronization. Argo CD takes like 3 minutes to sync our to try to refresh our repository, our Git repository, to know if there's any change. So if you commit to the to our Git repository in the next 3 minutes, Argo CD will check, and if you find any new changes, Argo CD will try to make these new changes available on our cluster. And also, how does Argo CD do this? Argo CD perform what we call sync. It sync our our cluster with our Git repository every 3 minutes, and this it has what we call edge check validity for new pod and traffic shift. So without wasting much of time, can you go on down again so we can talk about the next part? So we'll talk about the self-healing here. Go up. 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 So for the self-healing here is that, let's say we make a changes into our cluster manually, maybe by using maybe kubectl, we spin up pod for maybe our application have 2 pod, and we manually change this our application to have 4 pod. What Argo CD will do is that with this self-healing action, Argo CD will make sure that what is on our manifest is what is going to be on our cluster. Argo CD will try to change this manual changes back to what is inside our manifest. That's what is inside our Git repository. So that's what they said. That's something about the self-healing. Go down, and for the next one is zero downtime. So for the Argo CD, we can have this what we call zero downtime. So with the zero downtime, we can set Argo CD, because let's say we have 2 pod, and we are spinning the 2 pod to 3 pod. So what we will do before is that it will first terminate the pod before creating a new pod. But with this zero downtime deployment, Argo CD will try to create the new pod before terminating the old pod, and it makes sure that the new pod is the one serving traffic before terminating the old pod. If the new pod is not serving the traffic, Argo CD will hold on until the new pod is the one serving the traffic before it terminates the pod. So this gives us a zero downtime, and all our application will be running. So can you go down?
It's okay, Kunle. Is any other person speaking because of time?
Okay,
Thank you
okay,
very much. Thank you. I've been following very well. Thank you.
okay.
Okay, is Umar there?
Go ahead.
Umar will take the observability stuff.
Please,
Yeah, I
because of time, just keep it 1 minute. Just go straight to the point. Okay.
thank you. So I'll just quickly run through the observability part which I took. So my name is Omar and I worked on the observability part. So basically for the observability we use Prometheus, um, Promptail, and Loki for the logs, and we use Grafana dashboard to assess the metrics and the logs. The script you are seeing up there is how we were able to install the Prometheus cube, the cube Prometheus stack with the help of a custom configuration file, which we have in the last part of the script. So the custom configuration part basically just contain the specification that we want, like the persistent kind of volume, the storage size, and other important parts. So for the Loki tool, it's the same thing. We use Helm to install the Loki stack with the help of the custom configuration file that is at the last part, the Loki values.yaml. So for the Prometheus, the implementation is for the local deployment, but for the Loki, we used Google Objects Storage. So inside the configuration file, the Loki.value.yaml file, it has all the specification like the type of buckets, the authentication, and the size, and the indexing method that we should use. So that's basically what the configuration file contains. It tells the script that you should use that particular configuration file. So like after the installation, the next thing is just to access the Grafana dashboard using the port forwarding on port 3000. And next thing is just to log in and Abdullah, please can you scroll to that last screenshot? Yes, you log in and we're able to add the data source. No, sorry, not the K9S. The one before the K9S. So basically, we were able to add the data source of the Prometheus and the Loki from there. And please scroll to the first screenshot. So that's how we're able to access the metrics and the logs. So I think I'll just end my, this one is quite straightforward. So if you have any comments, thank you.
Thank you. Mr. Kabir Bello.
Yes, I'm here. Thank you very much. So, good evening, everyone. My name is Kabir Bello. The part which I'm taking is the Velero backup and disaster recovery. So the Velero provides production-grade backup and disaster recovery capabilities for the Kubernetes clusters. It backs up all cluster resources to the Google Cloud Storage, and this enables command restoration in disaster scenarios. So why do we choose the Velero? The main purpose of choosing the Velero is to back up all Kubernetes resources, including deployment, service, config maps, secret, and persistent volumes. Can you please scroll down? Okay. So not to talk much of your time, I want to talk on the architecture. Okay. So it has 5 layers. The layer 1 is the mini finance cluster. This houses the application, which is the Fintech application. We have the layer 2, which is the Velero pod. This is the backup agent running inside the cluster. The main job of the Velero pod is to take snapshots of the state files, and this stores the state files outside the cluster. it stores it in a bucket outside the cluster. So this runs on a dedicated namespace called Velero. Okay, so the third layer is the workload identity. This is the authentication bridge between the cluster and the GCP. This is the best practice. No password or key file is required. Okay, so we have the layer 4, which is the GCP service account. This is the GCP identity that Velero assumes when talking to Google Cloud. The permission is set. The permission attached to this to the service account is the object admin, which allows Velero to read, write, list, and delete from the bucket. Okay, so the last on the list, the last layer, which is the bucket, as I rightly said earlier, the bucket stores the snapshots of the state files, and this is created outside the cluster. So this simply means that in case of disaster recovery, even when the cluster is down or it is mistakenly deleted or an hacker hacked the cluster, we'll still be able to restore the backup because it is stored outside the cluster. So why workload identity over key files? Why do we choose the workload identity over key files? The main reason is no JSON key files to manage, rotate, or secure. Eliminate risk of stolen or leaked credentials. What we mean by this is in key files, if we use key files for the connection, key file uses secret, and the secret can be exposed. So automatic rotation by GCP recommended security best practices. So connecting the cluster and the bucket outside the cluster using the workload is the best practice. Can you please scroll down? Can you please scroll down, please? Okay, so these are the steps. Please wait. These are the steps which we use in creating the backup. We created okay. So we created the bucket first outside the cluster, and the bucket is in the same availability zone as the as the GKE. So we use US Central 1 to create the bucket, and we also use US Central 1 to create the GKE. So versioning, the main purpose of us versioning the bucket is store all Velero backups with versioning project against accidental deletion. So create Google Cloud Storage bucket that will serve as a destination for all Velero backups. This bucket needs to be in the same region as your GKE. This is what I explained earlier. For optimal performance and to comply with the data residency requirements. If you check the picture, can you scroll back a bit? That particular picture is the picture of the bucket which you created outside the cluster. Please scroll up. Scroll up. Okay, so the second step is to create this.
Time is up, 𝗘𝗍𝗱. Because of time, because I need to give feedback, and Team F has not presented, and it's almost 10 p.m.
Okay. Can you give me some minutes to round up?
No, it's fine. Time is no. You took like 6 minutes already. Okay. Who else has not presented?
I think the last part is just a refresher by Kunle. So after this disaster recovery.
Okay. Can you scroll down?
Kunle, no. Kunle, don't present again. There's no time.
Okay.
Who else has not spoken?
No, I think we've all participated in this, except a member of us who pulled out along the way. 𝗘𝗍𝗱 pulled out and he exited the group. A member of us pulled out. 𝗘𝗍𝗱 pulled out of the group. Yes. So we all participated.
We also add how we can reproduce this into an application under this our guide, the steps to take and all the command we use in creating this application is stated under this our documentation slides.
So, and in addition to what Kunle said, this is a blog which anyone can visit. So if you want to read more, or if you want to have insight of what we've done, the link to the blog is going to be provided, and anyone can have access to it. Thank you.
Right. So thank you so much, guys. I was trying to evaluate your work with your expected deliverable, and I didn't see anything that was missing. The last person that spoke was wait, is it wait, who is the last person that spoke?
Kabir.
Okay.
No, Kabir. So Kabir, was it you that talked about auto-scaling?
I am the one that talked about auto-scaling.
Talked about auto-scaling.
And observability.
Umar will talk about
Right.
observability.
So what about backup? That was what Kabir talked about.
Yes,
disaster recovery. Yes. Yes, disaster
Alright,
recovery.
so
Backup and disaster recovery.
yeah, so well done, guys. I was following up and I didn't see anything you guys missed. So it was really end to end. I must say, you guys did a good job so far with the whole work, and it's very, very impressive. It's just that next time when you're presenting, trying to keep it within time. The presentation took over 30-something minutes, which is not supposed to, because the other team will still need to talk and we need to also close early. So well done, guys. Like, I don't know how to say this, but this is the first time seeing this kind of thing within a DevOps team. So well done. I am so proud of what you guys have done, and I just hope that it was a learning journey. Let me just give 1 or 2 persons to just take 1 minute to tell me what the learning journey was for you doing this project. Anybody can speak from Team E.
Okay, I'm going to go first, and any of the team member is going to go next. The learning journey has been wonderful. For me, being a newbie in DevOps, I was able to learn a lot. I've not used the Google Cloud before, but this gave me the avenue to sit down and learn about Google Cloud. And I've used applications like the Prometheus and Grafana before, but it gave me the insight. And this is the first time of me using Argo CD, and it gave me the insight on how to use all these tools. And this has been a great experience. Over to my team members.
Okay, Omar, you want to speak?
Yes. So I wanted to correct Kabir earlier when you asked the question. You mentioned Abdulrahman, and I'm Abdulrahman as well, and I'm Omar. So, like, just to be sure, the person that left is Mohammed's colleague.
Is who?
Mohammed's colleague. So, if you take note of that, look at Abdulrahman.
Okay, Abubakar Sadiq, right? Thank you so much. Thank you, guys. Thank you so much. So what you do is give me the link to the blog. Give me your presentation slide, the one you guys use for the presentation demo, the odd week presentation, the slide that contains the architecture and other things, and then the link to this blog. Just give it to me ASAP. You can drop it this night. I need to make you guys this post, and then give me the list of everybody that participated as well. Just mention their names for me, and you guys, I gave us a form to fill where you are supposed to fill your LinkedIn URL, but Kabira, please get everybody's LinkedIn URL to send
Okay.
them to me together with the link to the blog and your slide.
Okay. We have been working on one of my team members has been working on the blog, and we are trying to we've included part of our LinkedIn to the blog. So once we perfect that, we are going to send everything to you.
All right, please let me get it before Sunday.
Okay. Thank you.
All right, thank you guys. Well done again. This is really impressive. Well done. Okay, so let's have Team F. Team F, are you ready? Enoch. Enoch, are you guys ready? Sheriff. Harajat.
Good day.
Good evening.
Good evening. Can you hear me?
Yes, we can hear you.
Can you see my screen?
It's visible.
All right.
Your line is kind of,
Can you hear?
your line is kind of
Can you hear me now?
breaking. Yeah, we can
Is it
hear
better
you.
now?
Yeah, better.
Good evening. My name is Enoch. I'm here to present for my team, Team F. And basically, we're all going to present together. Sorry, our project, which is PD DevOps platform, and we have documentation. I'm just going to highlight it, speak to it, and my team members will join during this presentation. So basically, this is our documentation, very, very detailed. And basically, what we're building is production-ready Kubernetes cluster on AWS, automated CI/CD pipeline on GitLab, and so many on. So this project was undertaken by 6 members that we all worked tirelessly. Going to go straight to the architecture because of our time. So before I move to the architecture, here's the responsibility of the 6 team members. I myself, I focused on the infrastructure and the leadership, where I oversee the AWS service configuration and the overall coordination of my team members. 𝗘𝘅𝗽𝗍 took over the Kubernetes applications, CI/CD and GitOps, in essential security, and 𝗘𝘅𝗽𝗍, the observability engineer. So let me just try my best to walk us through the architecture of the projects. So the developer that is pushing code to GitLab, and this could be a new feature, a bug fix, or any code change. So GitLab CI/CD immediately kicks in and automatically runs our test suits. So it builds Docker containers, images, and packages everything up. So after all this happens, basically without manual intervention. So based on this architecture, so the next thing is applying raw and using tools like 𝗘𝘅𝗽𝗍 to check for vulnerabilities in our container images. And basically that's for if critical vulnerabilities are found. So once the image passes through the security check, it pushes through AWS ECR, which is Elastic Container Registry, and that secures private registry for all our container images. From there, we move to Argo CD. That's our GitOps tool, which detects new images, and it orchestrates the deployment of our Kubernetes cluster, which is running on AWS EKS. So the EKS cluster is where all our application components run, and within the cluster, we have Argo CD, managing deployments, Prometheus, and Grafana monitoring everything. So this architecture just gives us like automation, it gives us security, observability, and scalability. So I'm just going to, and this document for anyone that wants to perform this projects. I put the recommendation on computer and at least 8 gigs in the AWS accounts, ability to use CLI, and an email address. So I took the first two because they are actually divided into chapters, and the first thing here is setting up your deployment. And it's actually very, very important that you set up your deployment because to be able to install everything that we need for our Play platform. So from installing Windows Observability for Linux, here is very well detailed. Down to installing WS CLI, and I put screenshots of it, very, very detailed, as I said. We installed Terraform, installed Helm, installed Git, Agro CD, and so on. So at the end of the day, we actually put, this was the Linux command that we used to verify that all of this was actually well installed. And as you can see right here, here is a screenshot of my own workstation here. So we're going to take this documentation, follow through this process, and be able to start with the foundation that your platform and everything that you're going to use is ready. Yeah, the next aspect is creating the AWS account. One of the reasons why I was very, very happy about this project is because I'd never actually used AWS, unlike Azure that I'm used to. So I actually went through documentations, and it was actually quite easy. And basically what I did was just to, the AWS account was actually provisioned by Inessential, and I was also able to create IAM role users. And the reason why I decided to create IAM role users because the root account is basically too powerful. So it's always best, which I think is always recommended, that we use IAM. So I was able to do that for all of my team members. And you can see right here is an overview of the dashboard of me creating for Sheriff, Quadri, myself, Aliyu, Ajara, and Essential. And of course, creating access keys. I did that exactly for each and every one of them. So I'm going to hand over to Quadri that's going to take over. Quadri, are you there?
Good evening, everyone. My name is Cody. So I took part the infrastructure part, so which I used Terraform to deploy the infrastructure on AWS. So apparently, Terraform is like CI/CD. So the reason why we is a infrastructure IAC infrastructure as a code to make the deployment. The reason why we have to use that because we are using an account that is not our own, because as you know, EKS is very expensive. So and we don't want to use by we provision anything and we forget to delete it so manually. So that's why we had to use Terraform. So Terraform will help us make sure that whatever we deploy, once we use Terraform destroy, you'll be able to destroy the infrastructure we created. So and you can scroll down. So so I set up a VPC, a subnet, NAT gateway, EKS cluster, then the worker stone. You can scroll down. Hello, you can scroll down. So these are all everything. So, but I still have towards the end. I want you to go to the where I put this. So Terraform the code. Go up ahead towards a bit. I made a fix to the GitHub repo. So that's the repo. So can you go to the repo? So GitHub repo. So just click on this repo so that we can see the repo of what we provision. I don't know. Can you hear me? You are going up. There's a repo I created before. Hello, can you hear me?
We can hear you.
So that GitHub repo where the infrastructure, yes, you can just click on it. It's a full image repository, so to show how the thing, and I even write a readme concerning that too. Hello, Enoch. Towards the end, there is a GitHub repo now that I say you should click. Up, go. No, this is the fourth. Is go up. Yes, just click on that. Yes, exactly. So that's the repo. So you can just open the repo to see the infrastructure that was being created. So it's public, so anybody can access it. So that's why. So I put up this how to set it up too. So if you want to set it up on yourself, you have the README. So the dependency that's required for it. So you can just use that as well. So you need to have AWS CLI, Terraform, install Terraform and everything on your PC before you can use Terraform. So once you use Terraform, you now specify the provider that wants to use. So the provider is AWS because we are using AWS, and one of our colleagues provide us AWS account. So I've given IAM. All of us are given IAM so that we can use to perform it our function. So with that IAM, I was able to provision the function on that account on the EU Western region so that everybody have now access to it. So which I'll be able to know. So I had to add some of my colleagues to the cluster manually. So I don't know. So if you check it, you will see a config I had to edit. So exactly. So go up. So this is the repository. That's the README concerning. That's the README for the repository. So this is everything, the architecture, the table of contents for the infrastructure. So basically, this is how the deployment is done. So that in case there's any issue, we don't want any situation where we'll be incurring cost on the account. So that's why we have to go for IAC so that it will be easier for us to terminate after our deployment. So that is just from my hand. So the next team member can take over. Thank you very much.
So whoever that is taking over, please just keep it within 2 minutes, okay? So that we can be able to maximize our time.
Good evening, everyone. I'm 𝗘𝗍𝗽𝗍 𝗟𝗯. So I was in charge with the structure of the applications and providing resource definition for Kubernetes. So the application follows a microservice-based architecture supported by container orchestration, which is Kubernetes. And the service, the divided into two different components. We have the front end and the back end. The back end uses two services, one for authentication and the other one for payment. While the front end just normal front end. So we use a relational database like Postgres and Docker for containerization, building images, then the Kubernetes orchestration for deployment. The resource structure, we have two major repositories where we host the application, one for the infrastructure and the other one for the developers. So I named the folder for each and every one of them. So for the source code, that is the one for the developers. The applications were provisioned, the service were like structured in folders. We have the auth service, everything concerning it, which include JSON Web Token, validation and user identity management, the payment service, handling payment process and transactional history. Then the dashboard, that is the front end. We use React Byte for the application. Then there's an init folder for database initialization. We use two different databases, one for user-related data, user-related storage, and the other one for the transaction. And we added C data to avoid implementing those manually. So there's a Docker Compose files for the developer to be able to build the image and run the container to see that everything is working the way they are supposed to. So there's also an infrastructure that is for the DevOps, a different repo. We separated them into two different repos. So each of the service that was created by the developers, we provide Kubernetes resources for them, and it was also structured in folders. The auth folder where the auth services is, the payment, the dashboard, then for Postgres. So there's a local Kubernetes environment, like a demo, where when we say we want to start straight on AWS, like provisioning everything on the cloud, as we are working on the deployment, bringing everything together, there's actually cost implications to that. So instead, we created a demo, a script file where everything can be configured by just running that script file. So the application image building, the Argo CD, Kubernetes resources, observability, everything. If you just run the script file, everything will just be provisioned. Then you can continue from wherever you stop. Then the changes you made, you are going to update the shell script. Then send everything to GitOps, so the next person can just pull your code and run the script to apply the changes you have made. The Docker configurations, it consists of the multi-stage building for image size. We use multi-stage building for image size. So the part that builds the image and the part that make everything run. That is the one that will be sending to Kubernetes.
All right. Cherif, time is up. So there is this thing with presentation, right? Especially when time is of essence. What you do is just speak to what you did in relation with what is expected. Okay, for instance, it is expected that there's going to be a CI/CD pipeline. Just talk about the CI/CD. You don't need to go into technical details because at the end of the day, we just talked about it. The audience are not going to follow because it is a technical detail. Just speak in line with what you did and how it affects your deliverable. It will help you to stay within the time frame. Okay. So well done so far, Team F. Well done. Well done. So who is speaking next?
My name is Ali Obakar. I was tasked with CI/CD pipeline, so I'll just give a high-level feel because of time. So the stacks I went with was GitHub Actions. I made use of Docker and Docker Hub, AWS, EKS. That's where the Kubernetes cluster was on. I used Argo CD. I also used Trivy for vulnerability scanning. I used YQ for editing and updating our manifest files with the image and their tags. And I also used Donny, which is an GitHub action. So the whole, I'm just going to try to summarize it. The whole workflow was to automate the whole process of updating applications code and images and pushing them live to our cluster. So I was able to achieve that using all of these tools. And I think if you scroll down, I dropped some screenshots of the deployment and the whole pipeline, the build stage, the scan, and how it flows from GitHub all the way to Argo CD and to the clusters themselves. So that's it from me.
Who's going next? Abubakar, are you done? Who is next? Enoch, who is going next?
Innocentia to go next, but she's not around. But Ajarat can.
All right.
Ajarat can go. Ajarat.
Okay. Good evening, everyone. I'm Ajarat. So I'll be talking about the observability. Enoch, please move there to the observability. Yeah, this is what I did. So we had an observability stack, which consists of 4 major components. That's the Prometheus for metrics, the Grafana for the dashboard, then the tracing and the log Elasticsearch. And we had the open telemetry. So the workflow was more like we instrumented the code, and from there, the payday applications was sending the data through the open telemetry collector which route traffic to the Prometheus and Grafana and traces to the Jaeger. So we use M to install all our key components, and we put it inside a particular namespace. That was the observability namespace. So from there, we had the Grafana dashboard that was used to monitor the CPU, memory usage, and also we had that of uptime. You can go down to the lower part. So these are all the pods running up. Go up a bit so I can show that that's the pod running on the observability namespace. Then these are the Grafana dashboard. We had the CPU. We were able to monitor the CPU usage, the memory usage, and also that of the uptime. So the whole purpose was just to be able to keep up with in real time how we use the memory and also the CPU. So that's the whole dashboard there. So that's my own part.
Who's going next?
I'm innocent how to go, but I think she has network issues. So I've called her, she's not online. So I think it's network issues. She dealt with the security aspect.
All right. So I'm coming. Let me get the delivery. What was your backup and restore strategy? I'm not sure I had that. Is anyone trying to speak? I'm trying to speak. Team F. Who is speaking for Team F? Enoch. Please, can anyone hear me? Am I speaking to myself?
Yeah,
Yes,
we
ma'am,
can
we
hear
can hear
you.
you.
Sorry.
All right. So
I think that particular task was given to Essential. She was supposed to talk on that. I think she implemented it using Zero.
okay. So there is another thing I want to ask. I like that you guys used IAC. Now, for instance, how do you handle incidents? I didn't ask this to Team E. So Team E, you guys will also need to give me this answer. How do you handle incident? For instance, okay, I think somebody in Team E spoke something very close. How do you handle incidents? Is there anything like self-healing implementations that you have in the workflow in a situation where, for instance, a pod is crashing and application is in a container that is running in that pod? How do you handle incidents? Is there a way that they can heal on their own? Is there a run book that a certain workflow is going to trigger? And all those things will be done without any human interference or any human involvement. Anybody within Team A or Team E or Team F should answer, please.
Yes, from our presentation, there is self-healing of the pods if in case of disaster or the pod is crashing, for example. Kunle made mention of that earlier. And Kunle, are you here? Is Kunle here? And this is part of the presentation we just did. Kunle took that part. Is Kunle here, please? Kunle? Okay, so I don't, yes, it is part of the presentation which we presented earlier. So self-healing is part of it, yeah. So I don't know if you, Kunle, are you here, please? Please, can you please speak on this?
Yes.
Please, can you speak on this, please? Thank you.
Yes. In our Argo CD manifest, there's a self-healing features there. So in case one of the queen in the pod crash, Argo CD will try to create a new pod, or it will make sure that the desire in state of that pod is there. And if the maybe if due to maybe workload, Argo CD will create a new pod if the pod crash. So the features is inside our Argo CD deployment. Everybody hear me?
Yes, I heard you. I heard you, and I heard when you talked about the Argo CD. Instead, I just wanted to iterate it. All right, thank you so much. Thank you. Anybody from Team F going to speak to that?
Actually, Kubernetes have a built-in self-healing process that once a pod crash, the kubelet inform the controller manager and other services that we spin up that pod again. And should in case after some number of tries, the pod is not able to not going to work properly, then the replica set will back to the previous version of that this thing that was working. So that is how then it will now notify the observability that there's something going wrong, the necessary alert to be made, then you will notify those that will fix the issue.
All right, good. So, well, it was, I'm seriously impressed, everyone. I don't want to buttress it further because the essence of this program is to force you to know. Forcing means that it is something you have to do for your part of the project, or for you to be able to contribute towards the project. That learning, this is something that you might not necessarily wake up on your own tomorrow and say, okay, I want to go and learn this. But because there is a task ahead, you have to learn. I am not very interested in the end goal. I'm more interested in the process and what the process teaches you, or what new thing can you add to your tech skills or your DevOps skill set, right? So that is why I'm not going to go deeper to answering more questions. I like that some of you worked in different aspects of this project, and let it be a starting point for you. Even though, if you ask me, when the whole program ends, you can go back to see if you can do this project all by yourself without needing anyone to help you. You're going to see a whole new perspective that you didn't know existed. And eventually, just ensure that you know what other guys did. For instance, there is part of auto scaling, there is part of security, there is part of backup and restore, there is CI/CD, there is IAC, and observability, and all those good stuff. Just understand, go through the overall documentation and understand what they did. You are not, this Expadox program is not the only place or the last place. This is the start of your career, meaning that there may be something that would come in your work sometime, and it is the knowledge that you got from the program that you can use to fix it. So just do yourself well by going to read the whole documentation to understand what other people did. And Team E, Team F, you can just read each other's project. You guys did well. Both teams did very, very well. I was wowed, and the whole project and the way it is done, it did exceed my expectations. So you guys did so well, and I like the fact that your teams are well coordinated, and this is to your team leads. Kudos to you guys for coordinating the team to do this awesome work and having everybody on the call to come and talk about it. And it was a very nice project, I must say. So you all do well to send me the link to your documentation. Team F, if your documentation is not on a blog yet, just send me the link to the what is it called, the doc, and I'm going to have to put it on a blog, and send me the LinkedIn profile URL of everybody on the team. Please let me get it before tonight. But I'll be working full-time next week and I won't have time to post, so I need to schedule the post tomorrow night. Let me get it, I beg of you guys. Let me get your slide, get your link to your blog or link to your documentation. You can put it on edit mode so I can be able to copy the images and the profile URL of everybody in your team. I think that should do. And then regarding your next project, I'm going to have to review the project 2 and what we have as project 3. Let me know which of them to give you guys. So just expect it tonight. And there won't be grace to have a 4-week to do one project again. I needed you guys to get familiar with this basic part first. So we're just going to have our normal 2 weeks. So when you get your project, while you're preparing for your odd week presentation, start working on the project full time. Just kickstart, like next week is the demo, so that it won't take you so much time to get it done. You wouldn't need to stretch yourself in that 1 week to get the whole project done. Just start everything. One person can be doing the slide, then every other person, or you guys just share it the way you see fit, but do the project halfway so you don't have any blockers in 2 weeks time when you have to come and talk about the actual work you did. But we're going to meet next week Friday for the presentation, for the odd week presentation. But just expect your next project before this night. I'm going to send it. So I don't know if anybody has anything to say. Okay, so I just take that there's nothing else to say, and I'm going to let everybody have their night back. See you guys next week Thursday, and well done for your A game. Everybody, well done on the work you guys have done so far. All right, good night, everyone.
Good night. Thank you very much.
Good night.
Have
Thank
a
you,
lovely
everyone.
night rest.
Yeah,
Thank you.
good night.